So today we are going to review how to graph and how to write equations of linear, piecewise defined functions. So first of all, function. What is a function? Well, when you look at a graph, for instance, I'm just going to draw a very simple graph. That's an XY axis. And let's say I come through and I draw a graph like this. How do I know if what you see in orange is a function? How many of you by a raise of hands remember vertical line test? Vertical line test will test it, okay? It's a test. So we make little dotted lines going straight down, and as long as every line that we create hits the line we're testing at most once, we consider it to be a function, okay? So everything I do, I know is going to be a function. Keep that in mind. So here's the first one. Please find your guided practice. Also have patience today, recognizing that the majority of students really feel confused about today. So we are going to write an equation of this function. It's made up of two pieces. So I'm start off the side, I write y equals. And in this position, I'll write the equations of the two pieces. Now this first one, I prefer to start on the left-hand side. This first one starts on the left, and it's a horizontal line. And if you've forgotten how to write the equation of a horizontal line, I can see it cuts through the y-axis at 3. That means this equation is y equals 3. And this equation down here is a straight linear line. So I'm going to use the formula y equals mx plus b. So first I identify b, which is the y-intercept. And then I have to identify what is the slope. So from left to right, I'm finding good intersection points. Left to right, I'm finding good intersection points. And I can see, even though we're going by, if you look closely here, you can see we're actually only going by increments of 0.5. Once you reduce it, it works out the same. So I'm going up 3 over 1, up 3 over 1. So this is y equals 3 over 1x plus 0. 3 over 1x plus 0. Yes, 3 over 1 is the same as 3, and you wouldn't have to put the 0 behind. Now, what do I do with that? So y equals 3, and then y equals 3x plus 0. Again, you can put a 1 underneath the 3, and you don't have to put a 0 there. We're half done with this problem. I want you to ask yourself, at what x value does this function stop? So you're going, and then what x value says, oh, stop, I'm done? Let's check. Is he correct? Is it -2? And what x value then does this function start? It also starts at -2. It's only x values that we're working with. So in this next section over here, it's only x values that we're concerned with. This function goes until -2. So I'm going to take and put some type of a writing utensil at -2. And I'm going to ask a question, but I actually don't want you to answer. I just want you to think of this. This particular function, it's to the left of -2. This pen is on -2. It's to the left of -2, which means it's smaller than -2 or it's less than -2. And so for that purpose, I make a less than sign. I do need to check. When it stops, it has a closed dot, which means I put a line underneath. Okay, our next piece, again, we're only concerned with x values. Our next piece starts at -2. And again, I'm going to put this pen up there. And we don't care if this line is going up or down or it's horizontal. All I want you to examine is it's to the right of -2, which means it's larger than -2 or greater than -2. Also notice that it has an open circle at -2, which means I do not put a line underneath, and this first example is done. Okay, do me a favor right now. Come down below, make a little asterisk, and I want you to write down one question right now if you have one. What seems a little complicated? What are you a little confused about with this problem? Write down one question. Okay, we're going to go on right now to independent practice number 1. How many pieces do I have to this function? 2. So I'm going to write y equals, and I'm going to leave space for 2 different functions. Now what's a little more difficult about this one is, again, I'm going to start out coming from the left. So this is the first function I would run into coming from the left. But this is not a horizontal line, so I need y equals mx plus b. So y equals, and instead of doing mx plus b, the part that's difficult is there's no b that I can see. So I need to find what is the pattern. So look for good intersection points, and I want you to dot them in. And then I want you to continue that pattern as you move upwards until you hit the y-axis. If you were going to extend that same line, where would it hit the y-axis? At what value? Anyone? Most people want to say -2, but these are actually going by increments of 0.5, so it would actually run into it at -1. So I'm going to write down here -1. And now what is the slope? Your slope is always determined from going from left to right. So from left to right, you're going up 2 over 1, up 2 over 1, 2 over 1x. Your next function is a little bit easier, the next portion, because it cuts through the y-axis and I can visually see that. So y equals, and it cuts through at 0. And what is the slope of this one? Up 1, right 2, up 1, right 2, up 1, right 2. In the past, a lot of students have forgotten when they write down the equation, they forget to add the x, or they forget their b portion, which is in this case 0 and -1, they forget to put a symbol in front, like a subtraction sign or a plus sign. Okay, so let's come over here and let's write the first function I see. So 2 over 1x subtract 1, and then 1/2 x plus 0. Some of you may be thinking, is it necessary to put a 1 on the bottom or a plus 0 in back? It's not. It's not necessary. It's just there so people understand. Okay, turn to your partner in 3 seconds. Where's that, like that imaginary line where it's an x value, it's always an x value, where one function comes to a stop and the next function starts? Tell your partner. It is not here. It is at an x value of -1. It is at an x value of -1. So this particular function here, I'm going to put my little pen here. This is to the left of -1, which means it is smaller or less than -1. So x is less than -1. It also has a closed dot at that point, so I put a line underneath. My second portion of this function, when I put my pen up there, is to the right of my line. So it is larger than or greater than -1. And there's an open circle at -1, so I do not put a line underneath.